So this problem is about running on rails. That's different from a previous problem which went downhill. And it says, suppose the voltage of the battery in the circuit in the drawing is 3.0 volts. The magnitude of the magnetic field directed perpendicular into the plane of the paper is 0.60 Tesla, and the length of the rod between the rails is 0.20 meters. Assuming that the rails are very long and have negligible resistance, find the maximum speed attained by the rod after the switch is closed. Okay, let's see what's gonna happen here. Once the switch is closed, there will be a current running this way, so down. So according to the right hand rule, the thumb is pointing down. The fingers are pointing into the paper, and that of course means that the palm is pointing to the right, so we would have a force here in this direction, which also means there is an acceleration in this direction, and therefore this rod will attain a certain velocity, which increasing velocity towards the right. I should actually put the direction of the electric current in here because that'll be important in a moment. So the electric current is going this way. Okay, now as this rod here has started moving with a certain velocity v, which increases, so this is not a constant velocity, a motional EMF with the units of volts is induced in the rod, written as velocity times magnetic field times the length of the rod. And you can see from the chapter what happens in this situation is that the charges are separated in such a way that the positive charges accumulate towards the top of the rod and the negative charges towards the bottom of the rod. And now imagine that this rod here has become kind of like the poles of a battery, where this one is the positive and over here is the negative pole of the battery, and the current therefore is gonna counteract flow in the opposite direction of the original current. So that current is going this way, opposing it. Okay, you can imagine that the faster this rod moves to the right, well, the larger, you can't imagine. It's obvious from the equation that the faster the rod moves to the right, the larger the electromotoric force gets, and therefore the more charge separation there is, and therefore the larger the current gets, until the current here going counterclockwise equals the current going clockwise, and therefore at some point that motional EMF is going to equal the voltage that is given. And at that point, since there is no more current flowing through the rod, no more net current flowing through the rod, the velocity of the rod will be constant, because there won't be any more magnetic force being exerted on it. And that's the velocity they want us to figure out, and I just wrote it down. The algebra is actually relatively simple. As you can see, V velocity equals the voltage given here, and again this here is same as the electromotoric force, E, the motional EMF, divided by B and L, and everything is given. So again, the algebra is actually really simple, but explaining it is a different ballpark. Okay, and the units will be in meters per second, because the EMF, the voltage, is given in volts, and the magnetic field in Tesla, and the length in meters, so all in standard units. This is the problem on the neon side sign, and it reads: a neon sign requires 12,000 volts for its operation. It operates from a 220 volt receptacle. What type of transformer, step up or step down, is needed? What must be the turns ratio NS over NP of the transformer? So a neon tube, neon sign, could operate with a much smaller voltage, but it's the electric field that needs to be applied all the way through here, and the longer the sign is, the higher the voltage needs to be in order to produce the same electric field that is required. So for a long neon sign here, like this tube here, you would need a higher voltage, and therefore a smaller tube could operate with 220 volts to produce the same electric field, but a longer sign would need more voltage. Alright, so it says that, I think I can type this, 220 volts is given, 12,000 volts is what is requested, and maybe if I make these bigger, there we go. And in order to get from here to there, of course, we would need a step-up transformer. And then, of course, the ratio NS over NP is simply going to be 12,000 volts divided by 220 volts, and when it's being plugged in, that is 55.5, or rounded to 55 to 1 as a ratio.